Hello guys, welcome back to another video. Today I'm just going to be talking about interesting quadratic equation problems that some of you might think is interesting. I don't know. These are a little bit difficult to solve. Okay, so first we're going to be talking about a quadratic equation problem where there is a variable with a power of 4. Right here, there's example. The second type of quadratic equation problem we're going to be talking about is quadratic equation problem where an absolute value of the variable we are trying to solve for is shown. The third type we're going to be talking about is a quadratic equation problem where there are denominators shown. And these types of divisions might throw off some people, but I'm just going to be explaining how to do these. And quadratic equation problems that lead to a cubic quadratic equation, and you're going to see what I'm talking about later in the video. First, when I saw this, with logical and critical thinking and a little bit of help from my grandfather, I was able to solve this, and I'm going to share this to you guys. There's a really simple solution that most Americans use that I see in YouTube videos. So first, what they do is they basically split minus 17x to the power of 2 by some numbers that when they multiply to each other, they will equal to this number, c. And then they make these common multiples of these numbers come out of these parentheses, and then they just make these go to a multiplication, and then it's easy to solve. X squared minus 1 is equal to 0, or x squared minus 16 is equal to 0, and then we can logically say that x equals plus or minus 1 or plus or minus 4. But we're not going to be talking about this type of solution, and I'm going to be talking about a different and easier to understand solution. Well, this is easier in its own way, but I think it's better to learn two types of solutions than one type of solution, in my opinion. So in a quadratic equation problem, the key thing we have to do is turn this into a quadratic equation. The first thing we see here is that these x squared is in the wrong place. We don't know what to do here. What I'm thinking of here is we have to make this x squared a number that is not powered so that it looks like a quadratic equation. So what I'm thinking of here is turning this x to the power of 4 to x squared squared, and this is gonna equal to x to the power of 4, but we still have this x squared in the middle of this equation. So what do? Well, it's pretty simple. If you want to make this look like a quadratic equation, we gotta make this area not powered by something, not powered by 2 or 3 or 4. So let's make x squared t, and we have x squared here, so this is going to turn into t, and this is going to turn into t squared. We have x squared here, so it's going to turn into minus 17t, and plus 16 is going to stay plus 16. And then we can just do the quadratic formula here, and we can find what solutions t has, 1 and 16. So we know that t equals to x squared, so x squared has the solution of 1 and 16. We know that no matter what type of number it is, negative or positive, if it's squared, then it's always going to be positive. So two types of solutions are plus minus 1. The third and fourth solution is plus or minus square root of 16, or plus 4 and minus 4. So we got these solutions easily as well, and these are same as this. So this is the first type of solution for this type of equation. This seems pretty confusing at first, but it's not really confusing. From the last equation, I mentioned that x squared is always a positive number no matter what x is. So it doesn't matter what if x is a negative number or a positive number. And we know that absolute value turns a number, no matter if it's negative or positive, it turns it into a positive number. So x squared is the same as positive value of x squared, and made absolute value of x equal to t. So now it's going to equal to 5t squared minus 8t plus 3 equal to 0. And we could just use the quadratic formula to find that t is equal to 1 or 0.6. And absolute value of x is 1 or 0.6. From this, we can simply say that x is equal to minus 1, 1 or minus 0.6, and 0.6, because this is just the absolute value of something. This isn't the solution. So yeah, x equals to plus or minus 1 and plus and minus 0.6. And we have to take into consideration that if t was less than 0, aka a negative number, so absolute value of x was a negative number, then x wouldn't equal to anything. It would be an empty set, because absolute value of something can't be less than 0. It can't be 0. It can be 0, and it can be a positive number, but it can't be a negative number. Therefore, it wouldn't have any solution, and we would just have two solutions. Okay, now this, we have divisions here. It kind of throws some people off, maybe, and it looks really weird, but this has an easy solution. Okay, just ignore the complexity of everything that is shown here. Just follow my lead. I multiplied these and this answer to 10, the common multiple of 2 and 5. We could have also multiplied it by 20, by 30, even by 40, but 10 is a simpler number and it's easier to use. We multiplied x plus 2 to the squared divided by 2 and 3x minus 1 squared divided by 5 and x plus 1 by 10. This 10 and this 2 would cancel each other out, leaving us with 5 times x plus 2 squared. This 10 and this 5 will cancel each other out, leaving us with 2 times 3x minus 1 squared. This just multiplies, and it will leave us with 10x plus 10. By the way, these two pluses are incorrect. They have to be minuses. Anyways, if you notice that x plus 2 squared can be expanded, then good job, because it can expand to x squared plus 4x plus 4. 3x minus 1 squared can be expanded as well, and it's going to leave us to minus 2 times 9x squared minus 6x plus 1. The answer stays the same, it doesn't change. And then we can take these out of these parentheses and multiply it by 5. So 5x squared plus 20x plus 20. The same happens to this. So minus 18x plus 12x minus 2 times 1 equals to minus 2, and answer stays the same. Now we can simplify this by subtracting 5x squared, 18x squared. We can add 20x and 12x, and we can subtract 20 and 2. So it's going to be minus 13x plus 32x plus 18, and this equals to the answer. Now what I want to do here, so that it becomes a quadratic equation, we can subtract both sides by minus 10x plus 10, and it's gonna leave us with this. Now we're gonna come back, and this gets subtracted by minus 10x minus 10, and same here. This leaves us with minus 13x squared plus 22x plus 8, and the answer becomes 0. Then on, we can use the quadratic formula to find the solutions for x. Minus 4 over 13 and 2. These two are the solutions for x, and this is how you can do quadratic equation problem if you see divisions. And now the final one is a quadratic equation problem that leads to a cubic quadratic equation, and you'll see what I'm talking about. So initially what I thought was, maybe you see the divisions here and you can just multiply these two and the answer by the common multiple, and I did that. So I multiplied this side and this side by the common multiple of x squared minus 9 and 3 minus x. And here x squared minus 9 cancels out with denominator x squared minus 9. Over here 3 minus x gets cancelled out by the denominator of 3 minus x. This just multiplies by 1 and it stays x squared minus 9, 3 minus x. Over here we are left with 3 minus x times 14, and it's going to leave us with 42 minus 14x, and over here we are left with x squared minus 9 times 1, so we're just going to be left with x squared minus 9. So we can just expand this because it looks unmanageable. This is gonna be 3x squared minus x cubed minus 27 plus 9x. And I think you know where the problem is. We can subtract both sides by 3x squared minus x cubed minus 27 plus 9. It's gonna leave us with x cubed minus 2x squared minus 23x plus 60 equals 0. In a quadratic equation problem, you're not supposed to use a cubic quadratic formula. I mean, if you know how to do this, but then good job, you can do this easily. But I don't think the teacher will be so enthusiastic about this if you use a cubic quadratic equation to solve this. I mean, this is correct, but we have to make this a quadratic equation. So how is it done correctly, you might ask? So this denominator over here, x squared minus 9, is equal to x squared minus 3 squared. And we can just expand this because these are the differences of squares, and it's gonna leave us with x minus 3 times x plus 3. And now we can just plug that in the denominator of this, and it's gonna leave us with 14 divided by x minus 3 times x plus 3. And this stays the same. So what I did here is I turned this to a minus 3 minus x, and this is going to leave us with 14 divided by x minus 3 times x plus 3 minus 1 divided by x minus 3. This minus comes over here, and this 3 minus x turns into a x minus 3. This minus x turns into a plus x, and this plus 3 turns into a minus 3. We see the common numbers in these denominators, but we still can't do anything. Okay, so what I did here is I changed the numerator by multiplying it by x plus 3. So it's gonna be 1 times x plus 3. But now this whole thing doesn't stay the same, and the answer is going to be off, and it's not going to equal to 1. So what I did here is I also multiplied the denominator by x plus 3. So now 1 times x plus 3 divided by x minus 3 times x plus 3 will be the same as 1 divided by x minus 3. And now we have same denominators, so I just smushed these numerators to each other. If two equations have the same denominator and it's subtracting each other, we can just smush the numerators to each other and denominators will stay the same, and it's going to be an individual division. This is going to be 14 minus 1 times x plus 3, like we said, divided by x minus 3 times x plus 3, and this equals to 14 minus x minus 3. We just expanded this minus 1 times x plus 3. Then denominator stays the same. We subtracted 14 and 3, leaving us with 11 minus x divided by x minus 3 times x plus 3. And now we know what 1 equals 2. So what I did here is I multiplied both sides by the denominator so that this division just disappears. So I multiplied it by x minus 3 times x plus 3, and I also multiply the answer by x minus 3 times x plus 3. So we are left with 11 minus x equals to x minus 3 times x plus 3. We expanded this again, and we know that this x squared minus 9 equals to x minus 3 times x plus 3. We're just going to be left with 11 minus x equals to x squared minus 9. And now what I did here is I subtracted both sides by x squared minus 9. So 11 minus x squared minus 9 equals to x squared minus 9 minus x squared minus 9. And this is going to leave us with minus x squared minus x plus 20 equals to 0. And from then on, we can just use the quadratic equation to find the solution for x. So now we have found the solutions in different and kind of difficult problems. I hope this was fun, and I hope this was informative. Peace.